Hello. So question is saying this, which of the following volume temperature plots, right? So this is the volume temperature plot represents the behavior of 1 mole of an ideal gas at 1 atmospheric pressure, right? So we have to find out the relationship between the behavior of the ideal gas between volume and temperature, right? So as we know that the ideal gas equation follow, or you can say looking like this. So this is PV is equals to nRT, right? So this is our ideal gas equation, right? So we have given the for 1 mole of an ideal gas, that means we have n is equal to 1 and 1 atmospheric pressure, that means pressure is equal to 1 atm, pressure is equals to 1 atm, right? And temperature is 273 Kelvin, right? So temperature is, you can see here, no temperature, we do not have temperature, right? So but here you can see this for the ideal behavior at this standard condition, if temperature is 273 Kelvin, right? So if temperature is 273 Kelvin, then volume must be 22.4 liter, right? So volume must be 22.4 liter, right? So this is the volume of the ideal gas at this condition, right? So now if we check the option, right? So if we check the option, you can see here, right? So we have a graph between volume and temperature, right? So volume and temperature, that means we have a constant pressure, we have a pressure constant, right? So that means these all graphs are at constant pressure. So I can say this, if pressure is constant, number of moles of gas is constant, right? And R is universal gas constant. So that means I can say this V is directly proportional to T, or you can say this V is equals to K, our proportionality constant, or which is equals to T, right? And so V by T, which becomes equals to, you can see here it is equals to K, right? So, or in other words, you can see, you can write this equation like this, V1 by T1, which is equals to V2 by T2, right? So this equation can be used to just verify the graph, right? So now you can see here in the graph, right? So you can see here in the graph second, you can see here at temperature 273 Kelvin, we have a given volume that is 20.4 liter, right? So we have given the volume that is 20.4 liter, right? So I can write here for this graph, you can see here we have temperature is 273 Kelvin, right? And pressure we have given in the question, that is 1 atm, right? So according to this, the volume should be, and the number of moles of gas is equal to 1, right? So according to this condition, the volume should be 22.4 liter, right? So 22.4 liter initial volume should be this, right? But here the volume is given at 20.4 liter, right? So that means this cannot be our answer, right? So this cannot be our answer, right? So now come to the option D, right? So you can see here in option D, the graph is decreasing, right? So but our formula is suggesting that V is directly proportional to T. That means if we plot a graph between V and T, so it must be straight line, right? So it is increasing order, right? So that means if the temperature is increasing, that means volume is increasing, right? So as all the three graphs are according to the formula, right? But the option D is not according to the formula, right? So this means that this option cannot be our answer, right? So this option cannot be our answer, right? However, at this initial position, volume is 22.4 liter, but graph is not according to the formula, right? So this is not the VT relationship, right? So this is also wrong, right? So now we are left with the option A and C, right? So now we are left with the option A and C, right? So if we calculate the option A, right? So if we calculate the option A and put the all value in the formula, and we can calculate the just for verification, so we can calculate it, right? So now you can see here we have a correct relation, right? So you can see at 273 we have a volume 22.4 liter, right? So that means if we can see here, this is our V1, right? So I can put here that is 22.4 divided by temperature is 273 Kelvin, right? So which is equals to, we can calculate final volume, right? So temperature we have given that is 373, right? So you can calculate it, right? So V2 you can calculate it, that is 22.4, right? So you can calculate it, that the value comes out to be 22.4 multiply 373 divided by 273, right? So if you multiply it to 22.4 multiply by 373, right? So and divide by 273, so you will get a value V2 which is equals to 30.60, right? So which is equals to 30.60 liter, right? So which is equals to 30.60 liter, right? So this is the volume we have calculated, right? But here you can see this, the volume is 38.8 liter, right? So that means this cannot be our answer, right? So this cannot be our answer, right? So now we are left with the option C, right? So we are left with the option C. Let's calculate for it, right? So now you can see here we have calculated it, right? So that means we have calculated that is volume is 30.60, right? So and this is all 30.60, and temperature, this is the initial condition and this is the correct condition, because at this temperature we have temperature 273 Kelvin, pressure is 1 atm, and for 1 mole of gas the volume should be 20.4 liter, and this is the correct answer, right? So this is the correct condition, right? And at this temperature we have this volume, right? So we have calculated it, right? So that means this is the correct relationship between V and T, right? So in this way I can say this option C will be the correct answer, and option C will be the correct answer, and rest of the option A, B and D will be the wrong answer, right? So hope this answered your question. So thank you.
Hello everyone, so in this question it is given the compressibility of a factor of a gas is less than unity at standard temperature pressure, therefore which of the following equation will be satisfied. So basically the compressibility factor is given as Z, which is equals to P V, the molar volume, by nRT. So in our question it is given that it is less than 1, that is our compressibility factor is given less than 1 at a standard temperature pressure. So at a standard temperature pressure, the value of pressure is 1 atm, the value of R is 0.0821 atm liter per Kelvin, and the value of temperature is 273 Kelvin. So this is the value of pressure, temperature and universal gas constant value at STP. Now by this inequality you can see here, if we have this, you can write it as PVM is less than nRT, because I have shifted this nRT to that side of the inequality. Like, what I'm trying to say is that I can write it more clearly, that here PVM by nRT is less than 1. So our PVM will less than n times RT. Now put the values of the standard temperature pressure, that is pressure is 1 atm, we have Vm as it is, we have 1 mole given, and we have 0.0821 value of universal gas constant, and we have a temperature of 273. So by solving this we get Vm less than 22.4 liters. So this is the condition, this inequality will be satisfied at when compressibility factor is less than 1, that is our Vm is less than 22.4 liters at STP. So if you check at the option here, option B is our correct one, which states that Vm is less than 22.4, and how it is coming I have shown you. I hope you got the concept.
Hey guys, question ये है कि the RMS velocity of hydrogen is √7 times the RMS velocity of nitrogen. If T is the temperature of the gas, then हमें हाइड्रोजन के टेम्परेचर और नाइट्रोजन के टेम्परेचर का रिलेशन बताना है, उनके RMS स्पीड का रिलेशन हमें प्रोवाइडेड है. सो लेट्स बिगिन. RMS URMS for hydrogen is √7 times for URMS for nitrogen. So RMS स्पीड क्या होती है? RMS स्पीड होती है 3RT by m. So for nitrogen we can write that URMS for nitrogen होगा √3RTN2 by nitrogen का मास होता है 28. Similarly we can write for hydrogen 3RTS2, हाइड्रोजन का मोलर मास है 2. सो जो इनिशियल एक्सप्रेशन हमें प्रोवाइडेड है उसके अंदर वैल्यू सब्स्टिट्यूट करता है. दिस विल बी 3R टेम्परेचर ऑफ हाइड्रोजन by 2 equals to √7 times 3R temperature of nitrogen by 28, squaring both sides हमें मिलेगा 3R temperature of hydrogen equals to 7 into 3R temperature of nitrogen by 28. 3R कैंसिल हो जाएगा, यहाँ होगा 14, दिस विल बी 2. सो हमें मिलेगा temperature of nitrogen will be 2 times of temperature of हाइड्रोजन। ये होगा इन दोनों के टेम्परेचर के बीच का रिलेशन। सो देखते हैं कौन सा ऑप्शन सही है। टेम्परेचर ऑफ हाइड्रोजन इक्वल्स टू टेम्परेचर ऑफ नाइट्रोजन, दिस इज फॉल्स। ऑप्शन सी हमारे पास करेक्ट ऑप्शन है।